I'm happy to be here. My name is Irene Cramer. I'm from Bosch Software Innovations, and I'm leading a team of developers and a team that develops and operates IoT analytics services in the Bosch IoT cloud. And what I would like to show you today is some of the use cases and some of the observations that we had in several data projects. I would like to first start to introduce the patterns that we are interested in. So the basic IoT analytics patterns that we are covering. I would like then to pick one specific pattern and show you a little bit more details in this pattern. It's the anomaly detection. Actually, I hope for giving a live demo. And although I tested it today and the technicians tested it, we were not able to make it run here. But I can show you offline, maybe if you're interested in after the session. The live demo. And at the end of the presentation, I would like to give you a brief context of how the services that my team is developing and operating is embedded from the architectural point of view in the IoT endeavor of Bosch. So, IoT analytics, what's that? What we can consider as given is, in all the use cases that we've seen, so for instance, use cases where we try to connect autonomous lawnmowers or coffee machines, or we also work with heating system data, everything that's in all the cases, what we can take as given is actually that we have a critical mass of devices, sensors, larger entities that are connected to the IoT. And these devices are sending events, typically, which are somewhat persisted. So regarding the data that's coming into a backend environment, there are lots of questions that could be asked about this data in order to explore, okay, what's that? What's in my devices? What's in the data that we get from the field? And one of the questions, or one of the things that could be of interest, and this is one of the topics and one of the use case patterns that we've seen pretty often, is people are interested in getting to know, okay, what actually are my users? What are the users of the coffee machines, of the lawnmowers, for instance? And they are not only interested in the typical user groups, they are also interested in whether they can map these devices or this behavior actually to personas. So to prototype, to prototypical users, like we see, for instance, in this slide. This is one of the patterns that we've seen quite often. So this is mapping, and this pattern is actually mapping to several IoT solutions or several IoT services that you could think of. The next pattern that we see pretty often is, now and then the devices are breaking down, and actually what people would like to know, they would like to know, okay, when does it happen and why does it happen? And what they would like to know most is before it actually happens, that it will happen. So this is the pattern that maps into the rest. So some people, especially if they try to predict that something is going to break down, some people call this, for instance, predictive maintenance or preventive maintenance. But there are also other patterns that fall into this field. And the other patterns, for instance, that people are interested, IoT project teams are interested in getting to know, do I have weak signals in my quality data? So do I have a quality problem with my devices? So is it just one device that's going to break down just because? Or do I have a bunch of devices that are going to break down because of the same reason, because something is wrong with the setup, with the device, with the design? And these are the two patterns that go in this direction. So what we found in the IoT solution that we've worked with, that we did analytics for, was that typically project teams do, in addition to the analysis of field data, what they in addition to is that they, for instance, equip a test fleet and run dedicated studies in order to find is there anything in my device that in this setup, in the installation, or in the quality that we should be looking for. The problem with this test fleet approach is typically it's pretty costly, and also it's limited regarding the data, and it typically has a specific scope, because typically what you're doing is you're setting up a specific test fleet here. So you're not having, you wouldn't have thousands of devices equipped, but what you would do is to have 10 of the devices in the field and then try to figure out what's going on. So the second approach that we've seen pretty often is the one of analyzing returns and feedback from customers. This is pretty nice because you get high quality data, and you can also do some kind of hands-on analysis of what's going on with your device. The problem there is you get the information from the customer when it's broken down, so maybe the customer is really not happy about what's going on with your data. So it might be a problem with your reputation, or it might cause problems with your reputation. And also doing manual inspection, that's pretty costly. So what we have as a key, in addition to these test fleet and returns and feedback, what we see as one of the interesting patterns is to analyze the field data in order to find out what's coming from all the devices that you have in your field. So you don't have a bias, for instance. Plus, you would also see things you're actually not looking for. So you would hopefully, or in many cases, you're able to find the unknown unknowns, so things that you're actually not expecting to be there. So this is one advantage. The problem with this approach is typically that people get a little bit lost when they see all the data and all the opportunities that what they could do with the data. They tend to, or there is the risk to getting lost in the full data and in the opportunities and the possibilities that you could do with the data. And that's why we came up with these patterns. So, and then in addition to that, why are we focusing on analytics actually? So why don't we write just rules or compute some basic statistics? Well, this is pretty tough to do, so it's quite a bit of work. In addition, as I said before, we are also interested in the unknown unknowns, and this is something you cannot model with rules, and you cannot find with statistics. Actually, you need to have some more powerful algorithms to really find these patterns. So what do we have in the Bosch IoT Analytics and the Bosch IoT Cloud? You see on the right-hand side, we have this productization arrow that's pointing to the left. And on the other side, you see the timeline. So what we did was we tried to come up, given the example projects, or given the projects that we've worked with, what we tried to come up with, we tried to condense the most important bits and pieces, the most important features, and also the most important requirements from these projects, and tried to productize this so that the blue examples are services where we try to come up with a set of these features that can be used in a self-service manner, while all the other ones are more in addition to the self-service manner, we have some things to do in a project setup. And this is what we mean by we have this productization in one direction and the timeline in the other direction. So what I would like to look in more detail into is the anomaly detection. And this is one of the things that fall in this, what happens when my devices break down, or what happens when something weird happens with my devices. And this is what I would like to show you in a little bit more details now. So what is an anomaly? An anomaly is actually something that I can observe in the data that is somehow different from what I have observed before and from what I expect to be there. And the advantage of this approach is, and this is really handy, especially in IoT project, because people in IoT projects typically just started to collect some data, they started to think about business cases, and what they typically have is they have some data, they may have lots of data, but they might not have all the data sets combined into one large data, all the bits and pieces and all the bits of information that they would need in order to do, for instance, a predictive maintenance use case, in order to, they don't have this in one data set, and therefore they don't have a labeled data set, meaning that they have a history of data, sensor values, and they also know that something has really broken down and how it was then worked with in the maintenance process. So the anomaly detection, the advantage of this one is it doesn't need to have any kind of labeled data. It can work with the data that you have and point you, hopefully, to things that are somehow strange. What it typically does is, in this case, we have some clusters. It doesn't need to be a clustering algorithm. It can be other algorithms. But what it does is it's computing on the basis of the data. It's computing some kind of clusters with dots scattering far away. And these dots scattering far away are typically the devices or the time frame within a device data set that point to something that was strange, somehow strange. The point here is that you need a domain expert to really analyze the result and then figuring out, okay, what was strange and why is this a red dot and not a green dot? So what we implemented in all the cases of the projects that we did was a process that included these steps. The first one is we are taking the historic data of a set of devices, the event data, and trying to to semantically enrich it, to generate new columns, to generate new features. And this is because typically the raw data needs to be enhanced, need to be added, so that we really can come up with the strange patterns. What we get as a result here would be, we get a feature table, and what we now need to do is we need to aggregate it over time. Why is that? Typically, devices send events whenever something changes. And this is not necessarily every minute or every second. So what we need to do is we need to take a certain time window and aggregate all the events that were in this time window so that we have an equidistant feature set. And in this step, you can also, when you have this aggregated data, for instance, what you can do is you can enhance it and again add some semantics to this feature set. And the last step of this process is typically to train the model. So this is done on the basis of the aggregated data. And what we try to do here is to come up with something that looks like a cluster when you plot it. Isn't it so? I give you an example. We did, for instance, a project with a lawnmower connected to the IoT. And what we used here was a multidimensional scaling algorithm. And this is a glance at this example algorithm. So what we have here in the original feature matrix, this is the aggregated data, right? What we are interested in is the distance between the individual devices in a certain time window. And if we get, this is here. If you have the distance, if you computed the distance, we get a distance matrix. And typically, if you have lots of sensor values, lots of features in your data set, and this is typical what you have in IoT data, what you need to do is, in order to see it then, for instance, in a visualization that something was an anomaly, what you need to do is you need to reduce the dimension of this matrix. So typically, this has a very high dimension. And what you try to do is you try to reduce the dimension in order to really have a representation that shows you the distances. So you try to reduce the dimension and retain as many bits of information as you had before in the distance matrix. And what you then try to do is that you get it to the lower dimension, and then what you can do is to plot it in a scatterplot like you see it here. And in this scatterplot, for instance, it's very easy to see that this one and this one is far away from the normal behavior, and therefore needs to have some manual inspection and some understanding from the domain expert and some exploration from the domain expert whether this was really something problematic, or maybe not only problematic, but maybe this could also be a business opportunity because something nice happened. But anyways, the point here is that you can analyze this in more details. So, how does our technical setup work? What we have is, we typically get the request of running this process that I showed you before. And what we then read is the analysis model that can be configured. In the case before, we had, for instance, configured that it's applying a certain anomaly detection algorithm, that it's applying certain kind of feature aggregation and aggregation over time. And this is what is modeled in this analysis model. And what we then have is we start a workflow engine that executing this actually then in our cloud environment, so that also larger data sets can be executed. So this would be then the point where I actually would have liked to show you my live demo. So I would like to say this again. I invite you to come after this session to me, and then I can show. I'm really happy to show you my live demo. So how is this embedded in the context of the IoT projects, and also in the context of the IoT architecture that Bosch is promoting? So the first thing that I would like to show you is that we compiled lots of different requirements coming in addition to the simple or the basic process that I've shown you before. In addition to that, we see that there are lots of additional requirements, especially coming from the data pre-processing and I/O area, especially that larger data sets can be processed, and also a rule-based pre-processing step that includes more semantics, that allows you to add more semantics to the data. The problem here again is, as the analysis of the results, the pre-processing typically involves manual effort. So a domain expert needs to think about what is a good feature, what is a good semantic that I could add to the raw data. What we also found, what was the typical pattern would be that we need to provide lots of visualizations in dashboards. And also, as I said before, when I showed you the clustering results, people would like to right-click on the red dots and then annotate it. For instance, if a domain expert analyzes this red dot, people would like to annotate and say, yeah, this was really an anomaly. This is where something then really broken down, or this is a quality problem, or this is something where we should act in a specific way. For instance, in our autonomous lawnmower project, people would be interested in annotating that in a certain case the lawnmower wasn't set up correctly, or that the lawnmower needs to have a new firmware. This was one of the patterns. So what we found here was that people would like to annotate and also automate the post-processing. For instance, in the example of the lawnmower, where we had this firmware update, this is something that you can automate, right? And then what we need to add also, what we found is in some of the cases, for instance, when we started with the lawnmower, we found that this is pretty similar to something that we've seen in heating system examples regarding the data analytics algorithms. But when we started then later with the greenhouse project, where we analyzed the data coming from greenhouses, we found that the data and also the algorithms are so different, And also the anomalies are so different that we needed to have more algorithms be implemented. And that's why we started to implement more algorithms and added them to the service. And then the final thing that many of the projects are interested in is actually how this is deployed. I've shown you before that we have this productization and timeline directions. And what people like to see in the projects that we've worked with was, in some cases, the IoT projects have some data scientists. For instance, in the heating systems example that we worked, they had very strong data scientists. And in these cases, the teams were most interested in a self-service mode of our cloud services. But in other cases, when the IoT projects just started with compiling the data and doing something with their data, for instance, the greenhouse example that we had, the project teams like to have something as a self-service to test, just to get to know what's actually possible. But then they need to have some really extensive project support coming from a data scientist team. What we also found was that we cannot really predict what environment and what other cloud services IoT projects need in order to really make sense out of the results that the analysis gives. And therefore, a rich environment regarding integration points, regarding other services is needed. I have some examples on the next slide. What is not possible with our services at the moment, because it's costly and it's also challenging, is if project teams want to see the services that we developed in another environment than the Bosch IT cloud or another cloud, that's a little bit a restriction. So, how is this embedded? This is the overall architecture of the Bosch IoT suite, and this also depicts some of the pieces of the Bosch IoT cloud. And the service that I've just shown you is a part of this Bosch IT Analytics service family. So this is a family of services that are covering the patterns that I've shown you before at the beginning of my presentation. And as you can see here, this analytics is connected via IoT Hub, Bosch IoT Hub, with the other Bosch IT suite services, for instance. So it could, for instance, take some data coming from the connectors, like, for instance, the lightweight M2M, and coming from these types of devices, for instance, from an e-bike or from a car, as you see here. It also can connect with the services that are managing and compiling all the information that are in a fleet of devices, for instance, the Bosch IoT things. The example that I've mentioned before, where we had these lawnmowers with an older version of a firmware, for instance, there's a connection with this rollout. So in order to automate the firmware update, as for example in the lawnmower example, could, for instance, be done with the rollouts service. And then we have, if you think of the wrong installation of the lawnmower that I've been talking before, what we need to do is integrate with the customer support team in order to then get in touch, for instance, with the customer. This is one possibility that you could think of. Get in touch with the customer and informing that, for instance, there is something wrong with the setup. And this could be, for instance, be done with the integration with the system. I've also mentioned before for the semantic enrichment that we need to have some preprocessing rules maybe. This can be done with the visual rules capability, for instance. So as you can see here, that's what I meant in my slide before. What you need in these projects is a rich environment of services. What's not shown in this slide is, for instance, the baseline or the base services as databases, or for also CP engines, which are part of the Bosch IoT cloud, and which can be taken as a resource for the analytics tasks that we do. So how is this embedded? actually, I hope for having this demo to embed this a little bit better. But the point is, we are on this level, on the solutions level, right? Customer or domain-specific solutions. And if you want to reuse the Bosch IoT Analytics in such an application, so this will be the application, this will be the solution level, what we can do is we can call the family, one of the services of this IoT Analytics family, we can call it, for instance, with REST interface. We can read and write from data sources in the Bosch IoT cloud, like from, for example, from a MongoDB, a Hadoop cluster. We also seen some use cases where they actually wanted to read some data from Splunk. And what we then do is we can write the results, for instance, as part of a visualization. We have some predefined dashboards, which you can reuse, or you can write the data back into a database in a certain format so that the IoT application can then read from there and trigger specific actions. So without my demo, this was pretty fast. But this is pretty much all I wanted to show you with my slides. So as I said before, I would be really, really happy to show some of you my demo afterwards. And now I think maybe you might have some questions. So you all seem to want to go to dinner.
Sorry. But can you shed some light on the big data architecture that you use to process the data? And what is that? I mean, when you start analyzing the data that comes in from the sensors and the models that you build. Does that make sense?
So you're referring to the big data environment.
Yes, yeah.
The point is, in most of the cases, it's not necessary to really process really big data, meaning huge amounts of historic data, just because all the use cases and all the examples that we've worked with were like this. They were interested in getting to know the anomalies, for instance, in a certain time frame, which would be 1 day or which would be 1 week. And to be honest, with our cloud environment, we were in all the cases able to manage these data sets. So we were not there was no need to really have special implementation of algorithms. What we found was, in order to really be able to run large data sets, was that we are working with microbatches, meaning in the cases, for instance, in the heating systems, this was the case. We would construct peaks on our own. If you collect all the data from 1 day from all the heating systems that are connected and then process this in the night, during the night, right? What they wanted to have was, they wanted to have the results of the anomalies in the mornings. So what we did was that we came up with a microbatch setup where we compiled smaller batches of this data set and processed them at the run, and then created the summary in the morning so that we didn't have to analyze all the data set in a short time frame. So in short, the answer to our setup is with having microbatches or working with event streams, although even if you actually need to process it once in a day, once in a week, we set on streams or on microbatches, and in this case, we never had something that exceeded the performance that we have with this setup. Okay?
Hello, a question. When you get a dot out from the group in the Scatterplot, what you do after? You have somebody to watch the plot, contact the customer, and plan some.
You mean the red dots, right?
Yeah, the one that are out from the group.
So the idea here is, as I said before, actually what we would like to do is we would like to predict these red dots before they happen. But this requires data where you have this annotation that this will be a red dot for the historic data in order to be able to predict it. So what we typically do at the moment with those red dots is that we ask domain experts to say, is it really a problem that happened there or not? And if they say, and this is our experience that we found was, domain experts are really fast in finding the patterns or the issue that was happening there. So if you show them just a few of these red dots, they don't want to look into all the data. They just want to see a small set of problems. And then they are really fast in saying, yeah, this is, as I said before, this is a problem with the firmware. And these red dots are all problems with the firmware. And what we can then do is we can annotate, meaning label them, these red dots, and say, okay, this is always a problem with the firmware. And then we are in the position to really train a model that's going to predict this before it happens, or that's automating the action how to handle these kind of problems. And this is what we are doing. So we are doing this in cycles. The first step will be, if you just don't have anything in order to train a prediction model, what we do is we try to help the domain experts, the IoT project teams, to speed up this creation of these richer data sets and of this post-processing automation by annotating these red dots. And in the next step, then, what we can do is to train a prediction model. This is the approach.
Hello, I am asking about, do you have any approaches of proactive anomaly detection within Bosch IoT ecosystem?
Can you repeat that?
I mean that if you have any proactive approaches within Bosch IoT ecosystem in order to detect any anomaly behaviors of the sensors?
Yeah, that's what I just shown, yeah. If you're interested, I can show you the demo of the software. Actually, we have a cloud server that's actually doing this.
Okay, thank you.
Okay. Any further questions? Okay, so then, many thanks.